Hello everyone, welcome to the Digital Systems and Architecture Practical Series. Today we'll be doing the topic ripple counter, 3-bit ripple counter. We'll see how we can make up a 3-bit ripple counter. So for a ripple counter we need to select the components. So I click here anywhere, okay, and then go to this miscellaneous digital. In that we select this, you can see this JK flip-flop, JKFF. We select this JKFF, there is JK flip-flop. We put it here. We need 3, so this is the first one, the second and the third one. So these are the 3 flip-flops. So first we select all the components, then we require the power supply. So we go to sources and power sources. We require a VCC power supply, so we take this VCC power supply, place it here, okay. Then we need a clock, okay. So where to get the clock? You can see here in the sources, okay, in the sources, and in this sources we have this signal voltage source, and here we can see the 4th option on the right. This is the clock voltage, okay. So we can select this clock voltage, we place it here. Now because clock voltage has requires a ground connection, so we again come back to power sources, and you can see here there is a ground, okay. This is the ground connection. We need to connect the ground to here. This is the ground connection, okay. So now the components have been selected, okay. Then we do the connections, okay. So the very first thing is we take this VCC, okay, and connect to the last J, and this connect this to the K. J and K are connected to VCC. Similarly the J and K of this are also connected to VCC, and similarly for this also, this J and the K are connected to the VCC, okay. Then we apply the clock, okay. First we connect the clock to the ground and connect this clock to the first flip-flop. Now the output of the first flip-flop, it will become the clock of the next flip-flop, and output of the second becomes the clock of the third one. So this completes the connection, okay. So these are the only connections we have to do. Now how to check the output? So here you can see we have some options, okay. The fourth one is, you can see, oscilloscope. So this is we have this is also, take the 5th one because there are 4 oscilloscopes in this case. So we select this one, okay. So here we select this one, okay. We just want to delete this, okay. So these are the 4 terminals. You can see this one, there are 4 terminals. So we connect the first terminal to the clock. This is how we connect. Then the second terminal to the output of the first flip-flop. Then the third to the output of the second flip-flop, and the 4th to the output of the third flip-flop, okay. And we can also connect the ground if you want. This is the ground G, okay. This ground is this is the common ground, okay. This is what we do the connection. Now next we can turn it on, okay. We can turn on the, okay, we can just run this application. So when we run, and to observe the waveform, you double click on this oscilloscope. Now this is what we'll see. So here there is an option reverse, so now we get a good screen. Now this, all the 4 waveforms, they are jumbled up. So how to separate it out? We need to separate all the 4 waveforms. So this is where we click on A. So we are on A, okay. And then we have to just check out this Y position. We just put it up. You can see this is the clock, the first waveform. We take it up, little bit up. Then we click here on we just turn the knob to the B position, okay, and then separate out the B wave, okay. We take it up, little bit up, okay. Then we click on knob C, okay, turn the knob to C and take it down, okay. We just click it down. So this is the third waveform, and then we take the knob to D, okay. This is D, and we take it more downwards. So these are the 4 waveforms, okay. Now because this waveform is too much closer, compressed one, so we can just separate it out. To separate, we just put the X position. You can see this X scale rather, okay. So this X scale is common to everyone. So we just put it down. We change the scale to 1 millisecond, okay. Now it is more 2 millisecond per division. So this is the output, okay. This output what we get, okay. I'll just stop it, okay. So now we can observe this first waveform. This is the clock. The clock becomes the output of the the output of the flip flop. This clock is given to the first flip flop, okay, and we get the output. This output is from the first flip flop. This output, the third waveform, is the output of the second flip flop, and the last one is the output of the third flip flop. So this is how it works, okay. So this is how the ripple counter works, okay. We can also do the counting, okay, the 0 0 0 0 0 1 and so on, okay. When it resets, you can see this is 0 0 0, then we have this, so it is actually resetted, sorry. So it will count in that particular sequence. It starts on 1 1 1, okay, then 1 1 0 and so on, okay. So we will get this 1 0 1, then 1 0 0 and so on. It is counting down, okay. So this is how a ripple counter works. So that's all for this particular session. Thanks for watching.